All right, so guys, welcome back to our class today. I didn't want to share the link to the general group. Very soon we'll stop sharing link. All right, so let's go. Now, first, what is machine? Please, if you can hear me, if you can actually hear me, please can you just drop a thumbs up? If you can hear me, please drop a thumbs up. Let me know that you can hear me before I proceed. If you can hear me, drop a thumbs up, please. Let's get it going. If you can hear me, drop a thumbs up, please. All right, so let's go. Let's start. Now, remember I said I'm not going to come here and be giving us stories upon stories upon stories. All you just need to do is that under each topic, I will expose you to the various ways questions can be asked. We solve problems and of course boost our confidence so that you can go on and solve lots and lots of problems. Now, machine, we all know what machine is. Machine is any device or anything at all that can help make work easier. Anything that can make work very easy for anybody, that is a machine. All right, for example, wheelbarrow is a machine because you use wheelbarrow to transport water. Okay, normally wheelbarrow carries more water than the human head or human hands. Wheelbarrow is a machine. Scissors is a machine because with the help of scissors you can actually cut stuff faster and better. So any substance that any equipment or device that can make work easier and faster can be called a machine. All right, now what are the terms? As far as machine is concerned, there are some terms that you're most likely going to come across in terms of calculations involving machines. We have the first one, velocity ratio. We have mechanical advantage and we have efficiency of the machine. So first, what is velocity ratio? From definition, mathematically, we said velocity ratio is a ratio. Ratio means division. All right, so anytime you hear ratio, ratio is always division. A ratio B is actually A divided by B. So this is more like saying this ratio is division. Take note of that. So whenever we say velocity ratio, what exactly are we referring to? We are referring to the distance moved by effort all over distance moved by load. Now let me explain something to us. Both effort and load, there are forces. Effort is a force needed to overcome that of a load. For example, if you want to lift up 20 liters from the ground, the 20 liters is a load, right? It's tending towards the ground. If you place 20 liters on top of a plastic chair or a plastic table that is not strong, that 20 liters of water is actually going to break that table. It means that the load has a weight that is always pointing downwards. Okay, so effort is actually the force required to overcome that of the load. So for me to be able to lift up the gallon, Please, can you hear me? I don't know what's my mic. I totally forgot to charge it yesterday after I shoot math class. Please, can you hear me? Like, is my voice better or is it echoing? Can I continue like this or I should charge my mic? Can you hear me, class? If you can hear me, I don't mind. I can continue. All right. So if you can hear me, let's continue. Sorry about that. This will not stop our class. So let me come closer. I said, you need to know the difference between effort and load. Because in most of the questions, they will not actually mention effort. They will not actually mention load. So most of the times they would mention it, and some other times they will not. So anytime somebody says effort, what is effort? Effort is a force that you need to overcome that of the load. I was trying to give us an illustration. I said, if you want to lift up 20 liters of water from the ground, that 20 liters of water is a load because it has weight. And weight is always tending downwards. And I even gave an illustration. I said, if you put 20 liters of water on top of a plastic chair, that 20 liters is going to, if the plastic chair is not really very strong, it's going to pierce through and of course it will break it. So effort is basically the amount of force that you need to overcome that of the weight or the load. If your force is not strong enough, you will not be able to lift up the 20 liters. That is why a 5-year-old child will not or cannot lift up a 20 liters of water because yes, that child is putting in force, but it is not enough to overcome the weight of the 20 liters. But if an adult lift up 20 liters, that adult have enough force to overcome the load. So take note of this, that majority of times they will not mention effort and load. We are going to see that in past question. So I said velocity ratio is basically the distance moved by effort all over distance moved by load. We have two formulas for velocity ratio. This is the first one, and we have for an inclined plane, right? For an inclined plane, velocity ratio is always 1 all over sine theta. What is an inclined plane? This is how it looks like. For example, you want to roll something from top of a lorry, right, to the ground. That is a machine. Let's say, for example, you want to bring down a very big generator, lister, from a big vehicle to the ground. Now you put something, for example, this is a vehicle. You put something here that comes to the ground. Now this is an inclined plane because this guy is inclining at an angle of theta to the horizontal. So for an inclined plane, velocity ratio has a formula of 1 all over sine theta. Please take note of this. Velocity ratio has two formulas. Distance moved by effort divided by distance moved by load. That is normal plane, or when there is no inclination. But for an inclined plane, where there is theta, theta is angle of inclination. And I gave a typical example. Many of us know this. Many of us that, let's assume you want to offload something from a lorry, a car. You want to bring down a car from a lorry that has container. Of course, you put something like this so that the car can drive down. This is a machine. It makes the car coming down easier. Remember, a machine is anything that can make work easier. So now, the velocity ratio for an inclined plane is always 1 over sine theta. Good. Now, we've talked about velocity ratio enough. Now, let's talk about mechanical advantage. Let's talk about mechanical advantage. I need to be very sure that you can hear me and that my voice is very clear. Please, just, is there any difference from when I had my mic? Or is still the same, or is still perfect? Please, I would love to know. Is there any difference from when I had my mic? Alright, somebody says okay. So let's look at the next. Alright, yes, the class is recorded. That's why I prefer YouTube. Once the class is done, YouTube automatically records it. Now, let's look at mechanical advantage. I said mechanical advantage is load all over effort. Simple. Please take note of this formula. For velocity ratio, we have two formulas. We have distance moved by effort, all over distance moved by load. Mechanical advantage is load over effort. Now, the third formula is efficiency. Right? Efficiency of a machine. Now, what is the formula for efficiency of a machine? Mechanical advantage, all velocity ratio times 100. And then the next formula says work output, like you're actually yourself, you're the one doing the work, which is work done by the load, and work input by the effort. Input is basically, okay, let me explain it properly. Output is load because you're trying to carry the load. You're the one inputting the energy, and the load is actually the one trying to drag you back. So if you want to lift something and you're not standing well, most likely you can fall. So we have work output, which is work done by the load, all over work input, work done by the effort, times 100. One thing about this topic is that all you just need to do is to remember the formulas. I'll walk you through step by step to solve lots and lots of questions. We have first question here. A plane inclined at an angle of 30 to the horizontal, exactly inclined plane. So this is it. This is the horizontal. Now this is a plane inclined at an angle of 30, has efficiency of 60%. The force parallel to the plane required to push the load of 120 Newton uniformly up the plane is dash. Please look at this question very well. So let's say this is a load that has 120 Newton. Class, for the fact that this guy is inclined, if you tilt a wood and put something on top of it, this object will always want to go down. So for you to push this guy up, you must put in effort. It is the effort that is going to drag it up. Remember, effort is the force required to overcome load. If your effort is not strong enough, this load would drag you and the effort down. But if your effort, that is the force you're trying to use to drag it up, if it is strong enough, you drag this guy up. Now they said, the force parallel to the plane. Now this is a plane.
parallel force is actually something like this. I mean, you know, parallel is actually something that is moving in the same direction, that they will never meet. So if this is a plane, there is a parallel force that is required to drag this guy. So they said the force parallel to the plane required to push the load of 120 Newton up the plane. If you notice, what they are asking you to find here is the effort. Remember, I told us that most of the time they will not mention effort. Effort is the force required to overcome a load. So they said the force parallel to the plane, this is a plane, right? If there is no force dragging this guy up, this guy will actually go down. To push the load of 120 up the plane is dash. So this is what we'll do. So we say, first, load equals to 120 Newton. Efficiency equals to 60%. Force, what? Okay, let's say effort. Theta, I repeat, it's not all the questions that they will mention effort. The force required to overcome a load is an effort. If you put effort in something, it means you're trying to actually see it work. So if something is trying to fall down and you're trying to drag it up, you're making effort. So if your force is strong enough, you can actually stop that from falling down and you drag it up. But if your force is not strong enough, that stuff will go down and take you alongside with it. Right? So that is why effort can be defined as the force required to overcome a load. In this question, you are asked to find the effort, but they did not mention the word effort. Alright? Now, you will come here and say efficiency, which is E, equals to mechanical advantage. I'll show us why, all over velocity ratio. Now, why did I use this formula? Please pardon me, let me take off this. Why did I use this formula? Why not the second one? Because they gave me efficiency, E. They gave me E to be 60%. They gave me effort. Effort is what I'm asked to find. They gave me load to be 120 Newton. They gave me theta to be 30. And they told me that it was an inclined plane. And based on what I have told us already, velocity ratio for an inclined plane is always 1 all over sine theta. Velocity ratio for an inclined plane is 1 over sine theta. Now, the question is, do I need velocity ratio? You're going to answer that question. So, for me to solve for effort, I know that mechanical advantage equals to load all over effort. Now, they gave me load. Effort is what I'm asked to find. I'll therefore say efficiency is mechanical advantage all over velocity ratio times 100. So this becomes 1 all over sine 30, because theta, this is the angle of inclination, was this guy 30. We're told that a plane inclined at an angle of 30 to the horizontal. So sine theta, this is 1 all over 0.5. And this becomes equals to 2. 1 all over 0.5 is 2. Now, Mechanical advantage is load all over effort. Load was given to me to be 120, so I come here and say 120 all over E. E is what I'm looking for. E is what I'm asked to find. So I'll come here and say, from this formula, I'll say 60 equals to, please, if they say 60%, it is 60 all over 100, but since there's already 100 here, you can just write 60, right? So this is 60. In place of mechanical advantage, I'll say 120 divided by E. All over, because efficiency is mechanical advantage all over velocity ratio. What is our velocity ratio? 2. Now, please, if you are following up to this point, please, I need a thumbs up. If you're following up to this point, you understand how we got to this point, please, I need a thumbs up. I need a thumbs up, please. Alright, so I like the fact that we are following. Class, let me actually show something. Let me show something. Now, I'll bring this 60. Okay, let's evaluate this guy. I'm trying to see how I can make it much easier for us now, so that we can understand this better. So let me write it this way. 60 equals to 120 divided by E all over 2 times 100. I can say 2 comes to this side, so I can cross multiply. This becomes 2 times 60 equals to 120 over E times 100. Now, this is 120 equals to 120 over E times 100. E can come to this side and multiply this. We now have 120 E equals to 120 times 100. Now, divide both. I can make E subject of the formula. I can divide both sides by 120. Right? I can say divide both sides by 120. Why? Because I want to find the value of E. So E becomes equals to, so we have 120 E divided by 120 equals to 120 times 100 over 120. So 120 cancels 120 E. This cancels this. Our answer becomes 100 Newton, which is option B. Please, if you understand this, okay, let me not ask those that understand. Okay, please, if you understand, give me a thumbs up. If you don't understand, please say no. If you understand, give me a thumbs up. If you don't understand, say no. Right? We have a lot of questions to solve. If you understand this calculation, give me a thumbs up. If you don't understand, say no. Alright, please, once again, let me resolve this for those persons that are confused, okay? Let me resolve this, then we proceed. So I'm going to resolve. Now, first, let me explain this again. We have a question here. They say a plane inclined at an angle of 30, right? For those persons that joined when I started, you will understand because I already gave us a breakdown. But if you did not join when I started, unfortunately, there is nothing I can do. You have to go back and rewatch the video because I already explained all the formulas before I proceeded. So if you came late, perhaps that is why you did not understand. A plane inclined at an angle of 30, theta is 30. To the horizontal has efficiency of 60. E 60%. The force parallel to the plane required to push the load. Class, the force required to push a load or required to overcome a load is always effort. That is effort. I repeat, the force required to push a load or required to overcome a load is always effort. So basically what they are asking us to find in this question is effort. Is effort. So the force parallel to the plane required to push the load of 120 is dash. So I'll say effort is not given. That is what I'm asked to find. The load is 120 Newton. 120 Newton. Now, how can I find load? They gave me efficiency, gave me theta, they gave me effort, and they gave me load. Remember, mechanical advantage is load all over effort. Also remember that velocity ratio is distance moved by effort all over distance moved by load. I'm recapping this formula. For an inclined plane, which this question is an inclined plane, a plane inclined at an angle of 30. Anytime you see a plane inclined at an angle, velocity ratio will be solved using this formula, 1 all over sine theta. Now, efficiency equals to mechanical advantage all over velocity ratio times 100. So if you look at this question here, efficiency is given, which is 60. Velocity ratio can be solved for. We can solve for velocity ratio because for an inclined plane, velocity ratio is 1 over sine theta, where theta is the angle. So in this case now, this becomes 1 over sine 30 because the angle is 30 degrees. So theta is angle. And they told us that for an inclined plane, velocity ratio is 1 over sine theta. So my velocity ratio becomes 1 over sine theta, which is equals to 2. I know efficiency, I know velocity ratio. What I do not know is mechanical advantage. But I know that mechanical advantage is load all over effort. So once I'm able to get my mechanical advantage, I know my load already. I can therefore solve for my effort. So I'm going to resolve this in a different way so that those that did not understand will understand. So I'll come here, anywhere I see efficiency, I'll put 60. So this is 60. Mechanical advantage was not given to me. What I am asked to find is load. But I know very well that if I know my mechanical advantage and I know my load already, which is 120, I can solve for my effort. So I'll say all over velocity ratio is 2 times 100. So cross multiply. 2 times 60 is 120 equals to mechanical advantage times 100. Make mechanical advantage subject of the formula. For me to make something subject of the formula, I'll divide both sides by whatever is attached to that thing. I want MA to stand alone, so I need to remove this 100. And what do? I divide both sides by 100. So I'll say divide both sides by 100. So this now becomes 120 all over 100 equals to MA times 100 all over 100. This cancels this. This. 12 divided by 10 is going to be 1.2. So mechanical advantage now becomes 12 divided by 10, which is 1.2. But they did not ask me for mechanical advantage. They asked me for effort. And they gave me load. Mechanical advantage equals to load all over effort. Anywhere I see mechanical advantage, I'll put 1.2. So this is 1.2 equals to load. They gave me load to be 120. All over effort. Let's call it E. Cross multiply. This is 1.2E equals to 120. I want E to stand alone, so I divide both sides by 1.2. E equals to, we have 1.2E divided by 1.2 equals to 120 divided by 1.2. So this cancels this. E becomes 100. So that is the answer to that. Option C. So those persons that did not understand, I don't know, is it better now? Or should we take more examples? Please, I need to know, especially those persons, a Woolum precious. I can be a Woolum check. Let's look at another question. There is another formula to solve this, right? I just switched. I wanted to use a different pattern to solve it so that those that did not understand will understand. But not to worry, I'll come back to this question, right? Let's solve another example, something that is a bit easier. Now we have the question here. Remember, all the questions we are solving, it is recorded, right? When I'm done, I'll just snap it and send. So if you have any question, please drop it on the group, on the paid group. I will respond to it. Okay? For some persons, you're seeing this thing for the very first time. So maybe you need to go through it again to understand it perfectly. Now let's look at these easier ones. I was supposed to start with the most simple question before moving to that guy. Now let's look at this guy. A machine has a velocity ratio. Of 5. It requires a force of 50 Newton to overcome a load of 200. Remember, the force required to overcome a load is always effort. Remember, the force required to overcome a load is always effort. Majority of times, they will not use the word effort. So, my effort equals to 50 Newton. It requires a force of 50 Newton to overcome a load equals to 200 Newton. What is efficiency? Class. First thing first, efficiency is always equals to mechanical advantage all over velocity ratio times 100. In this question, they have given us velocity ratio. They said a machine has a velocity ratio of 5. But if you look through the question, they did not give us mechanical advantage directly. They did not say the mechanical advantage is this. But we know that mechanical advantage is load all over effort. Which means, if they give me load and they give me effort, I can solve for mechanical advantage. Are you seeing what is happening here? So I'll say, so therefore, mechanical advantage is load all over effort. Now, what is the load here? 200. What is the effort here? 50. Now the answer becomes equals to 4. Because 200 divided by 50 is 4. So our mechanical advantage equals to 4. So which means, I now know my velocity ratio to be 5. I now know my mechanical advantage to be 4. I'll now come to the efficiency because I'm asked to find the efficiency. I'll therefore say, mechanical advantage is 4. All over, velocity ratio is 5 times 100. 4 times 100 is 400, divided by 5 is 80. Please, if you understand how I got this, please, I need a thumbs up. If you have any question, please ask. We have a lot of questions to solve today. This is my past question. We have a lot of questions to solve today. If you understand this, please, I need a thumbs up. If you have any question, please ask. Alright, good evening everybody. Please, after this class, Joy is going to share the link and place it on the page member group. So, just be informed about it. So, we'll share another link. Hopefully, please, once the link is shared, please tap on the link. Thank you. Abike is the same, is actually different questions. So we can't use the same formula all the time. So it's basically different questions. Do you understand? Now, anytime you're asked to find efficiency of a machine, the formula for efficiency is always mechanical advantage all over velocity ratio times 100. And the funny thing is that most of the times they will not always give you mechanical advantage directly. They will give you mechanical advantage in form of efforts and load. So once they give you effort and once they give you load, you can use it to solve for mechanical advantage, because mechanical advantage is load all over effort. Now, I said they will not always mention effort directly. Effort is a force required to overcome a load. Now look at this. They say it requires a force of 50 Newton to overcome a load of 200. The force required to overcome a load is effort. That was how we got this effort to be 50 and load to be 200. Velocity ratio was given to us to be 5 already. Mechanical advantage was load all over effort. So for me to get my load, for me to get my mechanical advantage, I need to say 200 divided by 50. Now I got this guy to be 4, and then I now say efficiency is mechanical advantage all over velocity ratio. In place of mechanical advantage, I'll put 4. In place of velocity ratio, I'll put 5 times 100. Let's solve more questions so that you can understand this guy better. Please, I'm preparing a summary for physics and chemistry. Alright, so any moment from now, I'll be sharing it on the group, so you can actually use it for your revision, okay? Topic by topic. I'll try as much as I can to post it on the paid member group. If you're not on the paid member group and you want to join, please send me a text so that I can join you. But remember, payment is involved. Very soon we'll stop doing classes for free for everybody. Let's look at this next one. Please, I want us to stop this question. So we have another question here. I want to first of all, trash almost all efficiency questions. Once I'm done with efficiency, we'll look at different other questions. If you notice, we have been solving similar type of questions for 3 times now, 3 consecutive times. The reason is because I want us to perfectly understand this, so that once I move away from that and introduce another type of question still under machine, you'll still be able to understand that one too. A machine has a velocity ratio of 4. So we'll say solution. A machine has a velocity ratio of 4. If it requires 800 Newton to overcome a load, remember I said the unit of force is Newton. The unit of force is Newton, which is capital letter N. A machine has a velocity ratio of 4. if it requires 800 Newton, to overcome a load, class, the force required to overcome a load is the effort. So it means that the effort is 800 Newton. And the load is 1600 Newton. They say efficiency is what? Remember that for you to solve efficiency, once velocity ratio is mentioned, efficiency is mechanical advantage all over velocity ratio times 100. That's efficiency. Now, mechanical advantage is not mentioned in this. You can see velocity ratio to be 4, but mechanical advantage is not mentioned. However, what is mentioned is effort and load. You now say, hold up, but mechanical advantage has a formula of load all over effort. What is a load? 16 Newton. What is the effort? 800 Newton. It means that my mechanical advantage will be 2. So I now have velocity ratio to be 4. I now have mechanical advantage to be 2. So therefore, efficiency will now be my mechanical advantage all over velocity ratio times 100. What is mechanical advantage? 2. What is velocity ratio? 4. 2 times 100 is 200. 200 divided by 4 is 50. I believe we all understand this now, so we can move to something else. If you have any question, please indicate. If you understand, just type I understand. Thank you. Let's look at another type of question still under this. All right. I like our ginger so much. Now let's move to something else. Now this question says, please be writing down this question in your note. Alright, so we have 3 questions here. How many can you guys answer, guys? How many can you answer? Now, let's look at this. They say an inclined plane of angle theta acting as a simple machine has a velocity ratio. Remember, velocity ratio has 2 formulas. Distance moved by effort over distance moved by load. That is the first one. Now the second one is for an inclined plane, right? For an inclined plane, velocity ratio is 1 over sine theta. So this is the correct one. Now the next one says an inclined plane which makes an angle of theta equals to 30 has a velocity ratio of that. So you come here and say for an inclined plane, velocity ratio is always 1 over sine theta. So this is 1 over sine 30, which is 1 over 0.5, which is equals to 2. As simple as that, right? The next one says a machine whose efficiency is 75%. So I'll come here and say, question 5, efficiency is 75%, is used to lift a load. A load is 1000 Newton. Calculate the effort. If the velocity ratio, please, this is 4. If the velocity ratio is 4, please, this is 4. Calculate the effort if the velocity ratio is 4. Now, first thing first, you need to know that efficiency equals to mechanical advantage all over velocity ratio times 100. That is the formula for efficiency. Now, mechanical advantage is load all over effort. Don't forget that. So I'll come here and say E equals, anywhere I see mechanical advantage, I know that it is load all over effort all over velocity ratio. Now, I remember that mechanical advantage equals to load all over effort. And efficiency has a formula of mechanical advantage all over velocity ratio times 100. But mechanical advantage is load all over effort. So anywhere I see M dot R, I'll put load all over effort. Alright? Divided by V dot R. So I'll come here. What is my efficiency? 75. What is my load? Load is 1000. What is my effort? E. I do not know. All over, what is my velocity ratio? 4. They gave me velocity ratio 4 for this question. Times 100. Now cross multiply. So this multiplies it. This becomes 75 times 4 equals to 75 times 4 is 300. So this is 300. Now this comes over to this side. we have 300 E equals to this. This cancels this, or you can just, okay, let's just say, I want to make E subject of the formula, so I'll divide both sides by 300. So when I divide both sides by 300, it becomes 300 E divided by 300 equals to 1000 times 100 divided by 300. This cancels this. E now becomes this. Now 1000 divided by 3 is what? Please help me press your calculator. 1000 divided by 3 is what? That should be 303 point something. Please help me press this calculator. Alright, so we have the option here is Newton. So let me give us something to try. Please, with what we have done now, all you just have to do is to try to solve lots and lots of questions. I've given us the concept, so maybe I'm just going to snap this page. I'll snap it now. Yes, on Monday I did not drop question because I already dropped a video. I wanted us to watch the video first before the question. So after this class, I'll just snap this page. This is a page. This contains everything about calculation under machines. Okay? This past question places questions topic by topic. So after this class, I'll be snapping this past question immediately, and then I'll tick the ones I want you to try. With what we have done now, we have exhausted or we have covered majority of the calculations under machines, right? So if you have any question, please ask me on the comment because I'm rounding up for this particular topic. Remember, this is calculations under machines. So if you have your textbook, right, you can just go through your textbook and maybe just run through it. Remember, this is a marathon class. We are dealing with, what I feel is necessary. So if you have textbook in physics, you can we have done the hard part. You can open your textbook and read. It now becomes easier and faster. So please, from next week, today is already Wednesday, I will no longer be dropping the link on the general group, right? The link is specifically for those that have registered. But I decided to be dropping it so that for those persons that have doubts of how our class looks like, so that you get to see how it looks like. But remember that the questions and all of that will only be dropped on the paid member group. But from next week, both our classes and everything will now be private. My YouTube will no longer be open for everybody. It will now be on private or unlisted. Only those that are approved to watch can watch. So if you're yet to register, please do well to text me so that I can enroll for the class. Alright, so we have actually used 1 hour to explain this. So the only thing remaining here is lots and lots of questions, which, like I said, I would like us to try. Right? Try to see how you can use your brain and understand, because everything we need, the formula is already here. The only thing you need to do extra is your ability to understand what they are asking you to do. That is just the issue. That first question I did, right? I'm going to drop it on the group. Again, I want you to attempt it. By tomorrow, I will drop the correction on that group, the paid member group. So please, do you have any questions to ask? All right. So in the absence of question, today's class ended very early because the topic is just straightforward. Know the formula for efficiency. We have two formulas. Maybe when I drop the question, I'll show us other ways you can answer that. But remember, we're still going to do a makeup, right? Just that this period has been stressful for me. I teach physical jam class as well. We have physical centers. So I teach in the physical and still teach online. So it's not really very easy. But we just have to do it. At the end of the day, your results is going to actually be the, what is going to encourage us more. So with this now, we have done machines. Machines are equipment or tools that makes work easier, right? Example of a common machine that we know, car is a machine. Car makes trekking easier, right? Car is a machine because it makes, trek. Normally, moving from one place to the other is very stressful, but car makes it very easy. Wheelbarrow is also a machine. Wheelbarrow helps us to convey goods, right? Basically, for example, water. Imagine trying to fetch water with your hands, right? It will take longer time, but if you use wheelbarrow, pack 4 or 5 gallons, before you know it, you're filled your goods up. So machines are any substance, or not substance, a device or equipment that makes work easier and faster. Now, we have types of machine, but we're not really going to go into that because in this class we are just focusing on calculation for this particular topic, right? But subsequently we can be looking at definition, but for this topic the calculations is more important. We have lever, pulley, axle, all of those guys are types of machine, right? Now, the terminologies in machine, we've seen velocity ratio, and I said velocity ratio has two formulas. The first one is distance moved by effort divided by distance moved by load. Now, the second formula for velocity ratio is when you have something inclined at an angle of theta. So for an inclined plane, velocity ratio is 1 over sine theta, which is this guy. Okay? Now, we move down to mechanical advantage. Mechanical advantage is load all over effort, which means if you are being given load and you are being given effort, you should be able to solve. But note this, majority of times they will not always mention the word effort. Now, effort is the force required to overcome a load. So, if they say a certain amount of load is overcome by a certain amount of force, it is the effort that is required to overcome that load. And effort, take note of that, is a force required to overcome a load. Mechanical advantage is load all over effort. Now we proceeded to talk about efficiency. So please, I'll drop a question. I'll just snap this page. I want us to try this night. This is 9:49. We started the class 9:40, so it's 1 hour 10 minutes or 1 hour 9 minutes. So please, from now till 11 p.m., I want us to attempt this question. I'll see you guys tomorrow, alright, in the next class. So in the meantime, if you're yet to register, please send me a message and sign up for our class immediately. I'll see you tomorrow. No, I'm not teaching another subject, but I will try and drop. I wanted to drop video for maths earlier, but I couldn't finish editing it on time. So I'll drop a video much later. So no more class today, no live class again. So teaching is over for today, just videos. Thank you.